mic mute. Right. Okay. So we're going to start the guys listen now. Right. So we're going to start the the second day of measurements, and I'll be doing one of the area volume questions as well in the middle. So firstly, we'll finish the vernier caliper, right? So we discuss how to calculate the the how to take the measurements and how to do the calculations and all. We discussed last week, right? So the today's session is about the parts of the vernier caliper and how do you use a vernier caliper, right? So I'll be giving you the vernier calipers, and you'll be taking the just like a few of the measurements you can take by yourself, because I'll be giving you the calipers. Right, now listen. So this is the vernier caliper, right? We already discussed this. So these are the parts of now these parts we have to label, right? So vernier caliper is a measuring instrument widely used in mechanical engineering and sort of like engineering stuff. Machines operators use calipers to measure diameters and etc. in their designs. This device is specially designed to be used for measuring the thickness of an object, right? Thickness of an object. Can you highlight it? Measuring the outer diameter, measuring the inner diameter, and the depth, right? Vernier calipers with least count 0.1 millimeter, 0.25 millimeter. Likewise, these least count can be there, right? Usually in the vernier calipers, these sort of different least counts are there. Yeah. Even that one that you have in your hand is 0.05 of a least count caliper, right? So they have like different the least counts. It can change, right? Right. Usually in school laboratories, the vernier caliper with minimum measurement of 0.1 millimeter is widely used. So usually the most usually vernier caliper has 0.1 millimeter of a least count, right? Mostly. The basic components of a vernier caliper can be identified as shown in the figure. So now, shall we label this? We have to label this. Now, tell me the parts. What are these two parts? Outer jaws, right? Label it. Outer jaws. These are outer jaws. And these two are? Bro, these are the inner jaws. You said it wrong. You said the outer jaws. And even I wrote it. Right? So these are inner jaws. Inner jaws. And these two are outer jaws. Right? And this is what? The vernier scale. Write the full sentence, vernier scale. You don't have to label it. Right? And what do you call this one? It's the lock screw. Lock screw. And what is this one? Main scale. This one is depth probe. This one is a depth probe. This one, rolling screw. This one is rolling screw. Right. These parts you have to know. Rarely there can be a structured essay of labeling the parts of the vernier caliper, but rarely, right? කියන්න බෑ ගොඩාක් chance එක අඩුයි. හැබැයි you have to know the parts, right? Right. Right, so the inner jaws, outer jaws, vernier scale is there in the middle, the lock screw to lock up the the moving part, and the rolling screw to to move the moving part, the main scale, depth probe. That's all, right? Yeah. So you labeled it? Yeah. You done labeling it? Yes. You ready? Right, now come to the stationary part. So no touching in the class. Take your hands off. Right. Stationary part, right? So stationary part, you can't move it, right? Come fast. Guys, be on time. 11:30 now. Right? So stationary part is the part that doesn't move, right? So it has how many parts of the the complete instrument? It has one outer jaw, right? It has one outer jaw in the stationary part. It has one outer jaw, one inner jaw, and the main scale. That's all, right? Yeah. No. The vernier scale is there in the moving part, right? So only three parts are there. The one outer jaw, one inner jaw, and a main scale. Right. The non-moving part of the vernier caliper is stationary part. It involves one outer jaw and one inner jaw. The main scale is also marked on the fixed part, right? So the moving part. So in the moving part, what can you see? One outer jaw is there, one inner jaw is there, and the vernier scale is there, and what else? Depth probe is there, right? Depth probe is there, right? So the moving parts that are designed to move along the stationary part, it includes one inner jaw and one outer jaw, which are not connected to the stationary part, is a part of this. Other than that, depth probe is also a part of this moving part. Vernier scale is marked on this part such that if it faces the main scale. Main scale එකට face කරන විදියට vernier scale එකත් මේකේ ඇඳලා තියෙන්නේ. Right? So those are very simple things, Right. So the outer jaws. Outer jaws are used to take readings in the outer surface of an object, right? Such as outer diameter of a cylinder, length of a small cube, and the thickness of a wooden strip. We will do that practically, not yourself. It's okay. Can you go to the this main room there in the corner, and there's a Kiehl's bag with me, plenty of vernier calipers. Can you bring it? Come faster. Yeah. Don't kill anyone, no? Now give me one of the calipers. Yeah. This is fine. Is it movable? Bro, that one is movable, right? Bro. Shall we exchange this one? This one. Right. So guys, listen. Right. So this is one of the vernier calipers. I'll be giving you a few so you can check. Now these are outer jaws, right? These two outer jaws. Using these two outer jaws, you can measure what? Outer diameter of a cylinder. If you take a cylinder, I'll take something like this. This pen is one of a cylinder. So you can put the, no, you can't kill anyone with that. You put it inside. Yeah, that's the depth probe. That's to measure the depth, right? Right. So these are the outer jaws, right? You put the cylinder in between the outer jaws and you stuck it between the jaws, right? Like this. And what you have to do? You have to lock the screw before taking the measurement. Now it's locked, so it won't move, right? Now what you have to do is there's two scales. One is vernier scale, the other one is the main scale. Now using these two scales, you can take the measurement, right? That's how you take the outer diameter of a cylinder. You put the cylinder horizontally in between the two of the jaws, and then you scroll it until it gets stuck, and you lock the screw, then you take the measurements, right? Simple as that. Can you guys share this? Share the vernier calipers and don't bring them, like, don't take them home. Keep it here. You'll be needing it back again. Right? So you'll be getting one caliper. And the length of a small metal cube. Let's say this one. So this is one of the small metal cubes, right? So I'm going to measure the, length of this metal cube. How are you going to do it? So again, using the outer diameters, you put the cube in between the two of jaws and you scroll it until it gets stuck, and you lock the screw, right? Lock the screw right like this, and then you take the measurement, right? You take the measurement, right? Like this. You keep it in between the two of the jaws, you stuck it, and you lock the screw, then you take the measurements, right? So that is using the outer jaws. And again, the thickness of a wooden strip. They say wooden strip. Even let's say this one is also a wooden strip. So how do you take it? You stuck it between the two of the outer jaws. Come fast, right? You stuck it between the two of the outer jaws. Then you lock it like this, right? Lock it like this. Then you take the thickness, right? Make a thickness. Measure gun pull. Yeah, don't kill him, right? Okay. Now, what else? Come to the tube. So you'll have a vernier caliper now. Yeah. So get used to it. Yeah. 0 to 0 me velane. Then it's a good one, right? You can practice it. So what sort of a error is there? A positive or a negative error? Positive error. Positive error. Then calculate the the positive 0 error, and then you have to add or deduct from the final measurement. You have to deduct, because if it is a positive 0 error, you have to deduct to get the correct one. Yeah, you have to, bro, there's a lock there. You have to push it. Likewise. Yeah, this. There? Huh? You can't? There's a lock there. Down there, there's a lock. You have to press it. Here. The rolling screw. The rolling screw is a sort of like a lock. You have to press it and take it back. Yeah, the whole thing. This is the rolling screw. No? So you press it. Like that. Then you slide it back. Oh, I'll give that. This one. Likewise. You can't see. Bro. Pavishka. The girl in the back is saying something here. She can't see it. Even Isuka. Right? Right. So you will have a vernier caliper now, right? Okay. So try to get used to it. Now come to this one, theory. To measure thickness of an object, the outer jaw should be placed as in the figure below, right? Since the thickness of an object may differ from point to point, taking readings from few places and taking the average of those readings is the standard procedure, right? So this is how you measure a thickness or a outer length of an object. How do you do it? Now you have the vernier, no? You take the object and you place it in between the outer jaws, right? Then you scroll it till it gets stuck and you lock the screw and you take the measurement, right? Do it with something. It's not working? And it's working, right? 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 Fine, anything. Right? So that is how you measure, a thickness or a length of an object, right? Anything. Right? That is the thickness. Fine, you measure it. How do you measure it? Now we'll come to that, right? Before measuring, like when you have the vernier caliper on your hands, there are things that you should. Kid. Right? People are really trying. I can see that. That's good. Yeah. When is killing it? There should be. It's been it's been oxidized, but still you can see the lines. Use a chalk. Draw a chalk line. If you have a chalk, you can have a chalk, right? Either use a pastel or a chalk and draw a line that the grooves will appear then. 2.3 millimeters of length of what? That one. I thought something else. Fine. Good. Like, you still don't know, right? Right? So that is how you measure the, using the outer jaws, right? So come to the next part. How do you use the inner jaws, right? Now we are going to use the inner jaws. Now you are done with the outer jaws, right? You measure with the outer jaws, right? So come to the inner jaws. Inner jaws are used to take the readings such as inner diameter of a mechanical bearing, inner diameter of a metal pipe. In order to get efficient readings, getting the average after taking few readings is advised. The following figure shows how to measure the inner diameter of a hole in mechanical bearing. Now we'll take one of the, something like this, right? I'm going to measure the inner diameter of this one, right? So how do you measure the inner diameter of this one? What you do is, you have to put the two inner jaws inside the cap, right? And you scroll it back so the cap gets stuck in the inner jaws, right? And what do? You lock the screw, right? Lock the screw, then you have to take the measurement, right? How do you do it? You put the bottle cap to the like you put the inner jaws inside the bottle cap and you scroll it back until it gets stuck. Now after it's stuck, you have to lock the screw and you take the measurement. You don't have it because you have this one. The rolling screw is the lock there. Some have like different locks, like even a rolling screw can be used as a lock, because this rolling screw doesn't lock. Only we have to lock by this. So depends. Some instruments have different things, but this is the typical one. You have to remember this one. So what is the inner diameter? So this is we are measuring the inner diameter, right? So have you tried it something? You have. Mark inner diameter right? So People online, I hope that you can see. So this is how you measure it, right? Got it? You lock here, then you lock the lock screw here, then you take the measurement using the vernier and the main scale, right? Right. Right? Then come to the depth probe. Listen. Depth probe, right? In instances such as measuring the depth of a hole, the depth probe is used. As shown in the figure below, depth probe is inserted to the hole and then the reading is taken by adjusting the outer jaws. To increase the accuracy of the reading, it is advisable to take several readings and then calculating the average, right? So how do you use the depth probe? Right? Let's say that this is an object with a depth. Let's say this is one of object which has a hole, like so. This is the depth of it, right? And it has a bottom as well. So I'm going to measure the depth. So how are you going to measure the depth here? You're going to put the edge of the vernier. You're going to connect the edge of the vernier to the edge of the object, right? You have to connect the edge to edge. Then what do? Then you you scroll down the depth probe. You see it going down, right? It has to go down like this until it hits the bottom, right? Bottom hit so when it hits the bottom, so don't break things, right? So when it hits the bottom, you gotta stop, right? When the depth probe hits the bottom, the edge should be connected to the edge of the object here, right? Now edge to edge has to be connected. Now the length of this, like this length from here to from the edge of the vernier to the end of the depth probe is the the depth, right? From the edge to the end of the depth probe is the depth of the object, right? Now you can measure it using these two, vernier and main scale, right? So you locate like this and you measure it, right? It's simple. So how do you do it? You put this edge to edge, you put the object edge to edge, then scroll down the depth probe until it hits the bottom, right? So once it hits the bottom, you have to check if the bottom to bottom, you have to check if the edge to edge is connected here. Then you take it off, lock the screw, take the measurement. Simple as that, right? Got it? Right? That is how you measure the depth. The depth එක measure කරනකොට always the edge to edge of the two objects have to be connected, right? මේ edge එකයි අර object එකේ edge එකයි connect වෙලා තියෙන්න ඕන මෙහෙම. මෙන්න මෙහෙම තියෙන්න ඕන. get it? ඊට පස්සේ මෙයාගේ bottom එකයි object එකේ bottom එකයි එකට connect වෙලා තියෙනවා. එතකොට තමයි මෙන්න මේ length එක හරියටම depth එක වෙන්නේ. get it? right. නිකම් මෙහෙම තියලා ගන්න බෑ. මෙහෙම ඇතුළට දාන්න බෑනේ. ඒතකොට භාගයක් විතර ගිහිල්ලා මේ edge එක තියෙන්න ඕන මේකේ edge එකේ. මෙහෙම තියෙන්න ඕන. එතකොට තමයි measurement එක ගන්න පුළුවන්. මෙන්න මෙහෙම edge to edge තියෙන්න ඕන. right? right. So listen, depth probe. In instances such as measuring the depth of a hole, this depth probe is used. As shown in the figure, depth probe is inserted to the hole and then the reading is taken by adjusting outer jaws. To increase the accuracy, you have to take several readings. Now, if you have to take, like even in the outer jaws or the inner jaws or the depth probe, when you're taking measurements, sometimes the length or the depth or the inner diameters may change from measurement to measurement, because like listen. Sometimes not sometimes, most of the time the instruments the objects that you measure are not uniform, you know. So this object isn't uniform. Like if I take diameters from here to here and here to here, those two diameters will be different because this is not uniform. The the shape is different from place to place. So if you have like if you got sort of a object, you have to take several measurements and you have to add together all the measurements and divide it by the number of measurements you took. That is the average of the measurements that you take, right? If you are like measuring the diameter, you have to take 2 or 3 diameters first, right? And will be different from place to place because this is not uniform. Then to get an accurate measurement, what you have to do? You have to add all the measurement and divide it by the number of measurements, and that you get the average measurement, right? In case of this is the average diameter. So that will be more accurate than taking one diameter, right? If you take one diameter and you write it as the diameter of this, it's not, right? Because the diameter changes from place to place. So in case of like that, what you have to do is you have to take several diameters, you have to take the several measurements and you add all the measurements together and divide it by the number of measurements you took, then you get the average, right? For all of the measurements, you have to do it like that because many of the objects that you measure are not uniform, right? So you have to take 2 or 3 measurements at least, right? So that is how you measure the depth, right? Now come to the locking screw. Locking screw helps to lock the vernier caliper when taking the reading. This prevents further movements and increase the accuracy. You already know that, right? Okay. Now come to the measuring using a vernier caliper, right? So when you are to measure something using a vernier caliper, what do you have to read first? You have the vernier caliper on your hands now. What are you going to check first? Yes, you can check if there is 0 error. That is correct. What else? What do you do when you have the vernier caliper on your hand? Now, if you have to take a measurement, you have to know the how do you take a measurement, complete measurement? First, you take you put the object between 2 of the jaws, and you check the main scale and the vernier scale, right? And you check the alignment of the vernier scale lines. And if like the 5th line is aligned, you have to take the vernier measurement using least count and the number of vernier lines that is aligned, right? So do you know the least count of an instrument? All of a sudden that you take it, do you know it? You don't know it. Sometimes, usually you don't know it, right? You took the vernier caliper, you don't know the least count. So in some cases, the vernier, some sort of verniers have the least count like mentioned on the instrument itself, right? But in some instrument it isn't. Can you like tell if you have the least count mentioned in the instrument? No, right? So in some instruments the least count isn't mentioned. Usually they're supposed to mention the least count, but if it wasn't, what are you supposed to do? You have to measure the least count. How do you measure the least count? You have to check the number of vernier lines aligned with the main scale lines. Now tell me how many vernier lines are aligned with how many main scale lines in your vernier? How many main scale lines are aligned with how many vernier scale lines there? Vernier nada? Now people who are online, can you show it to the camera? I'll tell when to adjust. That is for the online people. Bro. Now I can only see yourself. I'll tell. Alright. No. Focus again. Nice. Like taking a selfie. No, it's not focusing it. Is it? People who are online just tell me it's. I don't know. Now come here. Come this way. Another stay there. Now show it to the camera. Is it readable? I don't think it is readable. Guys, can you read it? I'll put a video. I'll put a video some later. Thank you. Thank you for cooperation. Right? So how many lines have aligned? With how many main scale lines? 9 with? 11 with how many? No, you don't count the 0. You don't count the 0. So how many vernier lines align with the main scale lines? 9. Now how many main scale lines, how many vernier scale lines? Tell separately. Main scale 9, vernier scale 10. Right. In some instrument it's different, na? You just check it. Now if you take this one, this has 20 divisions. You know, this one has 20 vernier scale divisions and 19 main scale divisions. Make a 19 main scale divisions, 20 vernier scale divisions or divide karpe metanati. You all must have like different. Now how many lines? 9, 10? 10 vernier lines. For sure? Shall I check? Show me. 1, 2, 3, 4, 5. Yeah, that's 10. You have also 10? Same. No, I think it's different. 1, 2. You don't count the 0. The first line is 0. You don't count it. Right? So mostly the verniers you have are like 10 vernier divisions aligned with 9 main scale divisions, right? Yeah. So first thing you have to do is you check for the least count, right? What you have to do is you have to check for the least count, because the least count is important when you are taking the measurements. When you are calculating the measurement, least count is important, right? Because when you are calculating the vernier scale value, what do? You multiply the least count by the vernier scale reading. So you have to know the least count to get the, to calculate the measurement, right? So the first thing you have to do is you have to find the least count. Shall we write it down? The first thing you have to finding the least count. Write down the first thing, finding the least count. Find the LC, right? You have to find the LC, find the least count, right? So all you found the least count? Did you all found the least count? No? Found it? 0.1. Okay. Same. 9 aligned with 10. How same? Only I have a different one. Okay. It's all same. 9 aligned with 10. Sure? Okay. Yeah, so most of the vernier calipers are 9 aligned with 10, but this one is aligned with like 20 vernier scale divisions aligned with 19 main scale division. Yeah, they are sort of like the least count here is 0.05. It's different from the other ones, right? Right. The second thing what you have to do is you have to check for the 0 errors, right? You have to check for the possible 0 errors. Right, check for the 0 errors. Then if there is no any 0 error, what do you have to do? Then you take the measurement, right? Taking the measurement. right? If there's no any zero error, you take the measurement, right? Right. Right. Reading measurements taken from the vernier caliper, right? So how do you, like, let's say you have put an object in between two of the jaws, now you have to measure the length of this. So how do you gonna measure the length of this? First thing is you have to check if there's a zero error, and if there's a zero error, you have to note it down, right? You have to calculate the zero error and you have to note it down, because you have to either deduct it or add it to the final measurement depending on the type of zero error. If it is a positive zero error, what do you have to do? You have to deduct it by the final measurement, and if it is a negative zero error, you have to add it, right? So first thing you have to do it, you write down the zero error first. Then once you put the object between two of the jaws, you have to take two measurements. What are the two measurements? One is the main scale value, the other one is vernier scale value. And finally, when you get the main scale and vernier scale values, you add them together to get the complete length, right? And once you get the complete length, if there was any of the zero errors, what do? You either deduct it or add it to the final measurement you took, right? Shall we write it down, right? Write it as a paragraph, doesn't matter. Write it as a paragraph. Write down, if there was any zero error, calculate if there was any zero error, calculate and note down the zero error, right? Hari. ඊට පස්සේ ලියන්න continue කරන්න එතන නම් once the object is kept between two of the jaws, take the main scale reading, within brackets liyanna. What is the main scale reading? How do you take the main scale reading? The main scale value just before the vernier 0, right? Within brackets liyanna main scale value just before the vernier 0. You wrote it? Main scale value just before the vernier 0. Close the brackets. Vernier 0. Main scale value just before the vernier 0, right? And take the vernier reading. Within brackets which is the number of vernier scale lines aligned with the main scale. Within brackets number of vernier scale lines which is aligned with the main scale. With the main scale. Number of vernier scale lines aligned with the main scale, right? Then what do? You multiply the least count by the vernier scale reading to get the Vernier scale value, right? ඒකත් ලියන්න. ඊට මදි වෙනවද? right. ඒක ලියන්න. කමන්න ලියන්න. හරි. Sticky note එකක් හරි දාන්න එතනින්. I ask you to bring the sticky notes. Right. ලියන්න you multiply the LC from VSR, multiply the LC from VSR, multiply the LC from VSR, multiply the LC from VSR to get the Vernier scale value. Yeah, Vernier scale value. Vernier scale value. Right. It is a final එක ගන්නේ කොහමද? Now you have to add the main scale value to the Vernier scale value to get the final length, right? You have to get the final length, to get the final length, to get the final length, to get the final length. Add MSV, add MSV, add MSV to VSV. Right. And finally, if there is any zero errors, you have to do the correction, right? If there is any zero error, 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 do the corrections. So you know the corrections, right? If it is a negative zero error, positive correction, positive zero error, negative correction, right? That's all. Right. Okay. So this is how, you know, like you take the outer diameter of a, let's say, a cylinder, right? You put the cylinder or if this could be like a sphere, you put the sphere or the cylinder in between the outer jaws, and then you lock the screw and take the measurement, right? The first, let's consider taking a reading from vernier caliper which least count is mentioned and no zero error, right? In this scenario, the first and second steps can be omitted because the least count is given. You don't have to measure the least count. And the second one is there is no zero error. So you don't have to measure any zero errors, right? So you can come to the third one, which is taking the measurement, right? Right. How do you take the measurement? Now this is the formula. How do you take it? Main scale reading plus vernier scale reading, and the main scale reading is the main scale value just before the vernier 0, and the vernier scale reading is LC into VSR, right? The least count into vernier scale reading, right? Right. So we have to calculate these things, you know. So in each and every calculation, you have to write down the formula. So what is the formula? Length equals MSV plus VSV, and the VSV is LC into VSR, right? You have to write it and apply the values, do the calculation. In the first one, what can you see? 0 to 0 has a line. So does it have any measurement? No, but still you have to write the whole formula and apply the values. Now the main scale value is 0, and the number of vernier scale lines aligned is, which line has a line? The 10th line has a line. If there's like, if the 10th line is aligned, take always the 10th line as 0. So 0.1 millimeter into 10th line, not 10th line, 0th line. Get it? Okay. Shall we do it fast? Write the formula. Right. So MSV is 0 plus 0.1 millimeter into VSR is again 0. So the length is 0. Yep.
මයික්‍රොමීටර් ස්ක්‍රූ ගේජ් එකේ මෙතන මේ 0 එකට උඩට මේ 45 ගියොත් නේද ඒක නෙගටිව් 0 එකක් තියෙන්නේ. මේක උඩින් තිබ්බොත් නේ.
ඕක නෙගටිව් තමයි. ඒ කියන්නේ මෙයාගෙන් ගන්න. මෙයා 0 එක පහු කරලා උඩට ගිහිල්ලා නම් පොසිටිව්. 0 එක පහු කරාම මෙයා 0 එක පහු කරාම උඩට ගිහිල්ලා නම් පොසිටිව්. එයා 0 එක පහු කරාම පිටපස්සට ගිහිල්ලා නම් නෙගටිව්. මෙයාගෙන් ගන්න.
මේ 0 එකට පල්ලෙන් 45 දෙනා නම් ඒක නෙගටිව්.
don't take like that. මෙන්න මේ ලයින් එක 0 එක පහු කරලා පිටිපස්සේ ඉන්නවා නම් නෙගටිව්. 0 එක පහු කරලා උඩ ඉන්නවා නම් ඒ කියන්නේ මෙයාගෙන් තමයි මෙෂර් කරන්නේ. මෙයා උඩට ගිහිල්ලා නම් පොසිටිව්. එයා යටට ගිහිල්ලා නම් නෙගටිව්. මෙයාගෙන් ගන්න. Right? Done? Now come to the second question. Following is another reading. Find the measurement. Make it read කරන්න. ඒකේ 0 to 0 align වෙලාද? නෑ. It has moved a little bit forward, right? So you have to measure the value. So which line has aligned here? Third line has aligned, right? Write down the formula, do the calculation. There's a box. In the next page, there's a box. Yeah. Do the answering in the box. Write down the formula, apply the values. Do the calculation. Get the final answer. Done? Done? What is the answer? 0.3. You got the same? Or you didn't do it? 0.3. Okay. So we have to write the complete formula first. So what is the formula? Length equals MSV plus VSV, and VSV is LC into VSR, right? So what is MSV here? MSV is always the value, the main scale value just before the vernier 0, which is 0, right? Yeah, which is 0. So MSV is 0. And what is the least count here? Is the least count given? No. So how do you take the least count? You have to check the number of vernier lines aligned with the main scale lines. So how many vernier lines have aligned with the main scale lines? How many main scale lines? Bro, 1. Now how many vernier lines do you see here? 1. Just tell me how many vernier lines are there? 10 vernier lines are there. Aligned with how many main scale lines? 9. So 9 aligned with 10 is usually what? 0.1 millimeters, right? You already know it. So where did you see 1 this year? You did answer 0.1. Okay. Right? So 0.1 millimeter into how many lines have aligned? Yeah, 3, right? 3 lines have aligned. So 3. What do you get here? 0.3 millimeters, right? So there will be difficult questions than these, like these are the basics. So metoda megana you have to think deep like. Now take this one. Do the calculation. Do the calculation. What are you looking at? The AC? That's fine. Bros need to chill, right? Fine. Now where's the AC remote? We double down, ready for in. Oh. Write down the formulas. Done? Right? Shall we check it? So you have to write the formula. Length equals MSV plus VSV, and the VSV is LC into VSR, right? So tell me the MSV here. Main scale value is the fourth main scale line, which is 4 millimeters, right? So the main scale value is 4 millimeters. Did you write anything else? Hands up those who took the main scale value as 4 millimeters. In centimeters, yes. In millimeters, it's the fourth line. Did you take it in centimeters or millimeters? Then 0.4. Then if you're taking it in centimeters, you have to take the least count as 0.01. That way it's fine. You got it as like what? 4 millimeter? 4 millimeter, then it's fine. Your face looks different. Face says something else. You took like 0. Bro, you have to take the main scale value just before the vernier 0. So now tell me, what is the main scale value just before the vernier 0? This is the vernier 0. The value just before the vernier 0 is 4th millimeter line of the main scale, right? So if you take it in millimeters, it should be 4 millimeters, right? 4 millimeters plus. Now what is the LC? 0.1. If 9 lines are aligned with the, 10 lines are aligned with the 9 millimeter lines, so it's 0.1 millimeters. So 0.1 millimeter into VSR is the number of aligned vernier scale lines, right? It is a 6. So that's 4.6 millimeters. Easy, right? 4.6 millimeters. Yes? I hope Shiny, Sajesh got the same answers. 4.6. Yes? Right. So that's it. That's all about the, the vernier scale, right? So we're gonna do some area volume calculations from now on, right? So come to the area and volume tute. Now put all the vernier calipers into the boxes. Shh, bro. You don't speak loudly. You don't do that. Ah, that's the proper way. Then yes. Right. Now listen. Yeah. Come quickly. Go straight. Right. Now come to this one. Right. So you have to find the perimeter. Listen. Right. So the first few questions are about the perimeter of the planar figures. So before you finding the the perimeter, there's something you should know. One of the theories. So there's something called radians. Have any of you have heard about the radians before? Yeah, radians. Yeah. So what is radian? What is a radian? How do you measure a radian? What is the formula for the radian? 2 pi r is the formula for the the circumference of a circle. Yes. What is a radian? Radian. No, radian. R. Yes, radian. What? Diameter එක දෙකට බෙදනවා. That's a half of a diameter. Diameter එක දෙකට බෙදුවාම half diameter. Ah yeah, that's the radius. Not the radius, bro. Radian. Ah yes. Radian is S over R. Radian. Not radius. Right? Radian. This. Radian. Come. So radian and radian is one of the the measuring units which is used to measure the angles apart from the degrees. So which one is the standard unit? Radians or the degrees? Radians is the standard unit, right? You might have used the degrees till now, but the standard unit of measuring the angles is not degrees, it's radians, right? So you have to use the radians. So now listen, right? So simply, what is a radian? How do you measure a radian? Radian is the circumference over radius ratio of a sector, right? Of any sector. If you have to find the angle value in radius, what you have to do is you divide the circumference by its radius, right? Let's say a sector like this, a semicircle, right? It has 180 degrees, right? That is in degrees. Now this has a circumference or the arc length of S and a radius of R, right? So if you have to find the the radian of this, what you have to do is you have to divide the S by R. That is what? Radians, right? You divide S by R, you get radians. So here in any of the semicircles that you get, right, in any size, the S over R ratio is always constant whatsoever the size of the semicircle, right? It could be larger, it could be smaller, any of it. If you divide the circumference by the radius, you be getting a constant value, which we call by a name. What? No. The constant have a different name. The constant have a different name. The S over R, like of a semicircle, if you divide the arc length by the radius, you get a constant value, and that constant value is what? Pi. The constant value is pi. Of any semicircle of any size, you divide the arc length by the radius, what do you get? The constant phi, which has a value 3.14 or 22 over 7. Get it? Yeah. So that's the way how you formulate the formula 2 phi r. When it comes to like a complete circle, so when it comes to a complete circle, the S over R length, S over R ratio will be what? S over R ratio will be, now the of a semicircle, the S over R ratio is 5. Of a complete circle, it should be twice that, right? So it's 2 phi. Get it? So S over R equals 2 phi, then S should be equal to 2 phi. That's how the formula was formulated. Did you already know this, or you just got to know this now? Got to know this now. Nice, right? So the radian is the base of it, you know. So if I take like a quarter circle like this, right, and it has an arc length of S, radius of R. Now the radian of this is S over R. If I take it in phi values, what could be the phi value? The half of the pi, right? Half of the pi. And do you see something? If I put the values in an order, 90 degrees is phi over 2, and 180 degrees is phi. 360 degrees is 2 phi. Do you see something? The degrees is proportional to the, the phi values, right, or the radian values. So instead of degrees, you can take the phi values, right, or the radian values, right? So it's same. It's increasing and decreasing proportionally, right? So since the degrees are proportional to the radians, instead of radians, you can still take the, instead of degrees, you can still take the radian values, right? So 90 degrees is phi over 2 radians, right? 180 degrees, it's how much? Phi radians. And 360 degrees, it is 2 phi radians. So instead of degrees, you can take the radians, right? Right. So do you understand that? Yeah. Bro, don't take the pictures. You get the recording, right? So now, first thing is you have to understand how to convert the degrees to what? Radians. How do you convert the degrees to the radians? There is one formula, or there is one logic for that. 180 degrees is how many radians? 180 degrees is how many radians? 5, right? 5 radians. And you want to find how much is 45 degrees in radians, right? So you simply divide this. How many 45s are there in 180? 4, right? 4. So how much is 45 degrees in radians? 5 over 4. Now the logic is this. Acharata mecharana. Yes. It's in single. Acharata මෙච්චර නම් අච්චරට මෙච්චර නම් මෙච්චරට කොච්චරද just know it in single, that's fine. අච්චරට මෙච්චර නම් මෙච්චරට කොච්චරද if 180 is 5 radians, how much of theta degrees is, right? That's the logic. Simple. If 180 degrees is 5 radians, how much is theta degrees, right? Using this you can convert the degrees into radians. Get it? Right. So shall we write down these theories in the first two boxes of the tute? Take the first two boxes of the tute and write down these things. Write down the formula here. Now the formula is what? The main formula. S equals R. Theta is the main formula, which SOR equals theta in radian, right? This theta is in radian. Bro, be like grown up. What are you doing? You're doing A-levels. Hey? ඔක්කොම දා පාට එක 180 degrees 360 degrees තුනම දා මේක 90 degrees මේක 360 degrees අච්චරට මෙච්චර නම් මෙච්චරට කොච්චරද right? Done? No? Done. Good. We have the question bank one here. Ravish, can I have it for a second? Right. So you'll be getting this question bank soon, right? So this is the question bank one, and you have these measurement questions. Right. There's not much. Right. Likewise, the measurement questions are there, and the area volume questions coming next, right? So this question bank will be, I'll be giving it really soon. And once you have the question bank, now this is model questions, you know. So these are the model questions, not the past paper ones. So you have to go through these ones, and afterwards I'll be giving the PPC one, which is the past paper classification. That is the past paper questions classified into, you know, the lessons. I'll be, yes, right. This is the 1 and 2 both are there. Now this is the past paper classification 1, and this is the second one. So this is the past paper questions classified, you know. Now this is area and volume. This is area and volume. So many questions are there, and the measurements questions are also there, right? Oh, this is microbiology right? Yes, right. And this is the question bank 2. Sorry, this is the PPC 2, and there will be like other question banks I'll be giving in the future. Tava papers I'll be giving you in the future. Fine. Right, now come to the first question. Right. Do the first question. Do this real quick. Yeah. The perimeter of this concentric segment is. Find the perimeter. So the perimeter should be the addition of 2Rs and L, right? So there is no 2R and L. So you have to find it in a different way. No, 2RL is not there. That is 2R, 2L. Can't be that. You have to find a different way. Now in the answers there is a theta as well, right? Theta value is also there. So do something with the theta, you know. The theta is given, so try to do something with the theta. So how do you combine the theta with the perimeter? You have to think. That's why the brain is there. Don't leave it like doing nothing. Just use your brain to think. Calculation එක නම් වෙන එකක් කරාට කමන්නේ. Answers okay මලිය. ඔව්. තාලදී. තාලදී. පුරු කියන්නේ. Recording එක දාලා නේ තිබ්බේ. Last week recording එක දාලා තිබ්බේ. දාලා You haven't out? Itu no? Oh kalian? Lihat balagan deh. Ngatain deh. Anyone who got the answer? Eh? Oh. Tough game. Eh? Phone? අපේ මොඩියුල් එක A15. ගේමින් ෆෝන්ස්ද තියෙනවා ඒ PS4 PS5 ඒවන තියෙන ෆෝන්ස් කියන්නේ මේකද මේක ටෆ් ගේමින් A15 එක Asus මේක locked up මේ ටෆ් එක login ටෆ් එක මේක ටෆ් එක මේක මට හම්බෙච්ච එකක් අතර මේක ෆින්ලන්ඩ් වලින් ආවේ මේක ඇති 4මාරක් වගේ ඈ ගාන ඩේලි ගාන වගේ ගේම් ගාන මේක මම ඔය ස්ටිමියුලේෂන් ඊට පස්සේ ප්‍රීමියර් ප්‍රෝ සොෆ්ට්වෙයාර් එකක් තමයි මොනවා ගේම්ද මං ගහන්නේ නැහැ ගේම්ස් බෝරු ගේම්ස් right done anybody who got the answer second one how did you get the answer did any of you apply radians into this did any of you apply radian into this no it apply radian into this otherwise how do you get the theta from where do you get the theta from apply the radians into this people online shiny any answers Sadesh what is the answer got any answers no why no how did you get the answer come on get it you have to come up with the reason you just can't tell the answers L theta එකට L theta එකට 2 S equals R theta හින්දාද so it's not L theta then it's R theta yeah R theta is equal to L so instead of L you can apply R theta right now these are very simple questions yeah these are very simple questions yes now there will be more harder questions than these things bro what are you thinking this is so go through the past paper questions you will see for yourself oh taan patan gatta idhar it's only started so how do you do it listen so the answer should be 2R plus L right if you take it in the you know the from the value from the labeled value that are given it should be 2R plus L but 2R plus L is not there right but instead there's theta so you have to somehow include theta into this so how and where the theta includes in a formula with a length that is S equals R theta right the arc length equals radius into radian theta so you put it right so S equals in case of this is L right L equals R theta. So the perimeter should be 2r plus L, right? This is the perimeter should be, right? But this answer is not there. So instead of L, we can apply what? R theta, right? So applying L equals R theta. What do you get? 2R plus, instead of L, R theta. Now R is common. You take out the R. What do you get? 2 plus theta. The answer is third one. R times theta plus 2, or the 2 plus theta. Answer is 3. Nobody get the answers before me, right? No one. Yeah, Tuna, you had to come up with the reason, right? Otherwise, no point. Right? Get the answer? Tube set take right? Now do this one. The value of the angle theta of the central segment shown in this figure is, they are asking for the theta value here in degrees, huh? Theta value in degrees. Got it? Anyone got the answer? Second question. Johan? Second one. Shall I do it? Get any answers? No. Approximate any answers? No. Second one, 125.2. How come? What is the logic? Estimated how? Huh? Assumed, yeah. How? Like, yeah. Still, you have to have a purpose. Can't just come with random things. Say I assumed it. Won't happen in the. Can't happen in the the A-levels. Anyone? Now, how did you assume it? Like, looking at the angle, it should be somewhere more than 90. Yeah, all the answers are above 90. So, I can't do it like this. That's not the way. Here. Any answers? No. Third one, 137. Why that? Because? Huh? No idea. Huh? Because he say, I can't do it like that. Protect again mind the him. You have to come up with a formula. Right? How do you Michelle? Shall I do it? Listen. Now listen. This is how you do it. So you know this ratio, right? But theta equals S over R, or just S equals R theta. I'll take the theta equals radian theta equals S over R. Now take the S over R value. So what is S here? 30, and the R is 10. So it should be 30 over 10. So which is the radian value is 3, right? So this is the the angle in radians. Now the radian value is 3. You have to convert this to degrees. So you already know phi is equal to 180. 5, if you take it in values, it is 3.14, right? So 3.14 is 180 degrees. You have to check how much is 3, right? 3.1, like this is how you convert it, no? Oh, ඒක තමයි. Radians එක degrees වලට convert කරනවා හරියට. So you already know phi is how much? 118 degrees. What you have to find is the theta value, right, in radians. So now the phi is 3.14, right? Phi is 3.14, which is 180 degrees. Now the radian value that you have is 3. So you have to divide this. So what is the simplest way? What is the simplest way? You can now assume it. This is where you assume, right? So this is where you assume. How do you assume now? Because 180 in radians is 5, which is 3.14. The value that you have is 3. It is approximately really close to 3.14. Then it should be somewhere near 180 degrees. Get it? Because 3.14 is 180 degrees. So 3 should be somewhere close to 180 degrees, right? So select the answer which is the the most closer to the 180 degrees. Which is the most close one? Yeah, the fourth one. That is when you assume, you don't do the calculation, you assume it. Otherwise, without any reason, without any purpose, you can't just assume, right? You can come to the assumptions, like you can use the short ways. You can assume the answers. That's one of the ways, Even to assume, right? Even to assume, you have to have the reasons to do so, right? You have to have the brain. Yes. Right? Even to assume, you have to have the the reasons to do so. Assume with reasons. So it should be 4, and if you simplify, you will get the same answer. Yeah, you get the same answer. Make a simplify, you will get the same answer. Got it? Shall I go to the next one? Check this one. This one is easy. Like the third question is easy. Do it. Shiny, did you get the second question's answer? For the people who are joining online, just put some text. Join with the the crew. They can't see it, but I'll read it for them. Done. Bro, this one is easy. Simple, right? You put 5r. Yeah. The semicircle, so you have to put 5r to get the circumference, right? E 2πr full circle again, this is a semicircle, now it's 5r. Half of 2πr is 5r, right? Okay, making me radiating hedun lisi. Got it? What is the answer? 80. As I remember, it's correct. What is the answer? Fourth. You got the same? Bros in the back. What is the answer? Yo. What is the answer? Fourth one. What's the answer? Here. What do you got? 80. Fourth or fifth? What is the answer? Fourth. Shall we check it? Now you had to get the perimeter, you have to calculate the arc length here, this arc length, and then you add 14 to it, right? So how do you get this arc length? S1. It's 5r, right? S1 equals 5r. 5r. So which is 5, 7, 22 over 7. R is 14. So how much do you get? 44, right? And this 2 is, again it's 5r, which is 22 over 7 into the r here is 7, right? R here is 7. So it's 22. So what are the values? You have to add 44, 22 and 14, right? Add 44, 22 and 14 together, what do you get? Yeah, so it's 46, 66, 66, 14 is 80. 80, right? 80 centimeters. So the answer is 4. Get it? So come to the next one. The angle subtended at the center of an arc of radius 10.5 centimeter is 45 degrees. The arc length is, they are asking for the arc length. Find the arc length. So what would be the formula for an arc length? 360 theta over 360 into 2 phi r. That is one way. Or else you can use what? Radians, right? S equals r theta. So to do that, you have to convert the degrees into radians. So 45 degrees is how many radians? 5 over 4. Use the radians. That's easy. Fifth answer. Did you use degrees or what? Did you use radians or degrees? Degrees. Use the radians. It's easy. Now you know how you use the degrees now. Now use radians. Yeah. Use the radians and which one is easier. Radian is easier. Now learn to use the radians. That's the thing. Right? First one. First answer. First answer. Got the same? Johan? First answer? First one? Did you use radians? 360 degrees. Theta over 360? Don't use it. No, fine. You use the degrees formula, no? Now use the radians formula and do it. And tell me which one is easier. Now learn to use the radians, because there will be more questions in the radians in LLS paper. Radians is used, right? So you have to learn how to apply the radians. So S equals R theta, right? S equals R theta. Use it. Radians are in the Tuna? I don't know. Okay. Maybe got that radians sorry. But so how do you take it using the radians? So radians is S equals R theta. Then the theta should be in radians. Yeah. You mean the R? Yeah, 10.5 into theta, which is 5 over R, 5 over 4, 5 over 4 years. So what is the formula you had to put? S equals R theta, yes? So yeah, it comes 8.2. Is the camera angle change? I don't know. This way is too far and this way is really close. Yeah, I think the camera angle has changed. Bro, what have you done? Now listen. Right? Bro, use the words, Right? So S equals R theta. Now you have to find the S. R is what? 10.5 centimeters. We'll put the the units afterwards. So theta is 5 over 4 because it's 45 degrees. 45, huh? Because 45 is, yeah, yes. So achharta mecharna 180 degrees is, sorry, 180 degrees is 5 radians. 45 degrees should be 5 over 4, right? So 5 over 4, right? So 10.5 into 5 is what? 22 over 7. And over 4 means 1 over 4, right? So if I take it in 3.5 values, how many 3.5 values are there in 10.5? Bro, no, 3. 3 into 3.5 is 10.5, right? So 3 3.5s are there. How many 3.5 there are in 7? 2. So it divides, right? Then what happens? This can be simplified. That's all, right? So 33 over 4. How divide 33 over 8.25, right? So the answer is 8.25. Now, isn't this easier than the the theta over 360 into 2 phi r formula? This is much easier, right? Isn't it? Yeah, but which one is easier? The first one? The honors, huh? But how many steps did it take for the the degrees way? Ah, the theta over 361? This. Yeah, even if you simplify with the the book, this takes lesser steps, right? So this only takes like two steps, right? Yeah, it took only 2 steps. So if you go like 360 over theta, that takes more steps than that, right? For simplifying, yeah, takes more steps. Yeah, yes. I didn't get go. Okay, okay. So that's it, right? So try the the 5th, 6th, 5th question, 6th question, and 7th question. Yeah, till the 7th question you just try it at home. No, till the 9th question. Till the 9th question you just try it at home. I will be discussing it next week. Sure. Okay. So now, give me all the vernier calipers you have. Put it in a box and give it to me. Now, where's the box of this one? Put it. Bro, everything is recording here, so use the words responsibly, otherwise I'll put the recording to your parents. Now this guy is speaking like this. Right?